must complete those two objectives by like 2 days before the exam. So this is what we expect yourself to do. So I would be, like working out with some questions. And I mean, like I said, this class, as long if you have time to sit, just sit on the computer long enough, so you should be able to handle all of these topics. But I don't want people to like spend 10 hours on one objective. That's going to be too much. But which is why I actually go over the majority of the topics. If whatever the topic that you don't understand, you can see the explanation along the way, or you can ask me during the office hour, and I would definitely go over that. You can work with your classmates, like I said, but the deadline cannot be extended. Okay, the deadline cannot be extended because we have to take the exams on September 12th. So so that's the only day that we must do it. We must, like complete like all the topics before you have to do the post module knowledge check before we can take the test. Okay, so which is why I'm trying to like go all the topics, and then if you have question, please ask. And no, I can't tell you, Chloe. Like I said, it's gonna violate the policy of the math department that, but I will give you some hints, like which topic that you should put more focus on during the exam review. Um, Next Tuesday. Okay, we have to take the exam on Friday. Are we good? So, um, so let's say I don't understand this question, I got it wrong, and then you can always see the explanation along the way. So this might be a little bit long to read all of that, right? But you know, and I would say this is a very important question. Whenever you say this is a very important question, you will have a high chance to see this kind of question on the exam. But there's no guarantee that um this will definitely be on the test. But I just want to let you know this is a very important topic. It talks about the sample statistics compared to the population parameters, so what the difference between these two, whatever it is. Okay. Um, all right. I believe this question is relatively straightforward, but I would say this is a very important question. Okay, very important question. So, the records of computer retail stores show that out of 100 customers who purchased the desktop computer last month, and 70 also purchased a Surface Plan that extended the warranty for an extra year out of 20 customers, and 12 of them purchased the same Surface Plan.
Mentioned in class today, I got another
So,
classmate of yours that
yeah.
told me that she can't.
So you have to compute the ratio for that, right?
She keeps
Obviously.
doing it wrong. Um, and yeah, just in general, I think all of like something like this happens, it might be like a system problem.
Pernah apakah suratmu? Pernah apakah suratmu? Kalau sudah ambil surat sih.
All right, make sure you're gonna mute your microphone if you don't have any questions to ask or, but anyway, so let's start off with the question that we have. Yeah, I would say this is a very important question, and let's do it.
These really insane. Um, I didn't.
All right, so last month the customers of a store who purchased which one?
They change, like the rules change every time, and I'm just like,
That's not, you would not be the only one.
Anyone can help me answer this question. The record of a computer. that's out of 100 customers. 70 will purchase service plan.
Yes. It's like, oh, you have to put this, you have to do this.
You got the, which one was,
Okay,
All right. So nobody want to answer the question. It's very straightforward. So we got 70 the purchase service plan. Um, will purchase out of 100 customers that extend the warranty for extra years, right? Obviously.
first thing that. For me,
So how can we do that?
like.
So we can find the ratio, like obviously this is not too bad. So we can take the ratio of P hat. Right, the P gonna be we're gonna take 70 over 100, something like that.
You're just dealing with multiplications and divisions. This actually becomes fairly simple because the answer is you want to distribute this exponent to.
So we have this one equal to 0.7. On the other hand, you're gonna have the so this is those who purchased the desktop, right? Yeah. So it's 12 out of 20. So out of 20 customer purchase a notebook, and then only 12 of them, right? So you can compute the P for notebook. So that would be 12 out of 20.
Or still, like say that we still.
Right? So the proportion is less likely. So this one we're gonna get like 0.6. So in other words, the people who purchase the desktop is actually more likely those who purchase the notebook with the same service plan, right? Obviously, so it's that is what we have. So we can solve this. Notebook was less likely to purchase. You only generate 60%. Whereas 70% the customer who bought the desktop, right? So all we have to do for this kind of question just simply compute the likelihood and see which one is bigger. Are we good? So this question is a very important question. And it's a very simple question as well, but it might be on the exam. Right? This is what I can tell.
You are gonna have to. Like,
Are we good?
Like this. Now. We haven't.
Okay.
The formula for.
Now we move up to the next topic.
You have to expand.
Where did we go to right now? Okay.
I'm with a cubic exponent. But.
So now for this kind of question, also a very important question, but this one's very straightforward.
So first of all, like,
how did we get the percentage? Oh yeah.
as soon as you get okay, that means that.
All right, let me go back to the previous question. I think I can't go back there, but I can go back to the note. So apparently that there'll be 70 out of 100 of those who purchased the desktop, right? And out of 12, 12 out of 20 customer will purchase the notebook. So we can just find the ratio.
So.
And then after we take 0.6.
More complicated example.
Can the student access to the page? You see all the topics. No, you cannot. So as a student, you're only allowed to go from topic to topic, but it should be showing on top of your screen, so you can go from one to another. But you don't see like the topic that we have, just what I have. You're gonna have like a big box on top of that. Yeah. Right. So you can choose the question you should do, or you can just do it immediately. I have students as well, while taking a class, that student actually move on to the topics by topics.
Yeah. Oh, yeah.
All right. I think that's pretty much fair for these questions. I know it's a very important question, but we have to move on. So now, so this is how we actually look at the mean and the range, or we call it the variation. So the team A has the range of 16 and the mean A was 36. And then the team B has the range of 7, the mean A was 42. The range is 13, the mean A was 38. And then the range was 15, the mean A was 44. Which one have the most variability? So the variability represent the range and the standard deviation. Okay, I'll let you know. So apparently that team A has the most variability. And which one has the oldest member? Like I said, is very straightforward. Like the D as the oldest members on average, right? So that's 44, right? It's very straightforward. So
in place of A
Sorry, can
and
you
find
go
and
over
finish
how you
the
got
work.
the
Let's
first
act
one?
like we
the
did
first
that.
one,
Let's not
this
do
one,
that. Let's do it like
this one,
No,
the way you would do it
the
like
A with the next
let's do it
question.
like the the long way.
the A
So
right here.
Yes.
Okay, so let me just point it out here. So the variability, right? Variability is basically the big range, okay? The range.
Guys, right?
So when we have like a big range, so that means that it's has the big variability, which is that there will be like a gap between each data set from the mean, right? So it generate like a bigger range. So apparently the question asked which one has the most variability. So A has the biggest range, which is 16, so it had to be team A. And team D has the oldest age on average, so that's 44. Are we good?
That is correct. If you do it one way and you do it another way and you get two different results, one of those two ways.
It's very straightforward.
But
Okay.
just
Just let me know because I have to move up to the most important question.
like there's a bunch of stuff that you could be doing. And it's not very intuitive, like what you want to
Yeah,
start.
you might see this question on the exam. It's a very
But,
important question. You have to know
whatever
how to read the Stanley plot. So given by like these diagrams, can someone help me find the range for those two class? So let me just copy that real quick. Okay, and
like A times B.
there was 23 students.
Like writing this is no different than writing this without any parentheses or with this parenthesis.
Oh yeah, just do it right here. So I don't think I have enough space for that, but like I said, it's I need to make sure that we have all the topics being answered before we move up to the next one.
J squared to the power times A to the power of 4. Okay. Let's leave the denominator as it was for now.
All right, guys. So can someone help me? What was the range for those two classes? Right? What is the range for 10 a.m. and what is the range for 11 a.m. based on the Stanley plot that we have here?
We multiply. So we are going to have, instead of J to the J squared to the 4th, we're gonna have we're gonna have J to the 8.
42, right? So we simply take the biggest value, which is 94, right?
So here
we take 94, which is the biggest value that we have, minus 52, right? Correct? So I'm confused. So we get 42. Are we good?
Exactly.
So the smallest data set. So look, we're going to look at the smallest data set for 10 a.m. or 52. The biggest data set is 94, right? So you can look at that. So this is 94. I need someone to help me out, right? And
oh, that was Jack.
yeah.
So
Are we good?
So now
so we know the fact that the range would be 42. No, we need to take the biggest. The range is the biggest minus the small, right? The range is the biggest minus the small.
So like let's not look across like vertically.
Okay.
So here, is there anything we can do?
In other words,
so
we have to take the biggest minus the smallest data set value. So the smallest one we have is 52 for 10 a.m. which is you have to read the number as 5 to 52.
Six, the same as the six.
And then the biggest number that we have is 94. So 94 minus 52 is 42, apparently.
So
Are we good?
that means that we can rewrite this if you want to put like just do like.
And then we do the same thing for 11 a.m. So we can simply take
The six, there's an exponent for that, but first we have to get to that point. So if we rewrite this.
we simply take the
in a
biggest
way
value,
that-
which is 87 minus 53. That is the smallest value for 11 a.m. You have to read it on the right. You have to read the value on the right. And then that essentially going to give us
And now we have our fine like
34. Are we good?
Um, X BA times X to the B is equal to X.
Okay, so now the question going to be asking which one has a higher median score. So you need to find a median among like 10 a.m. and 11 a.m. So I don't have enough space for that. So literally we have to find a median based on the number of data set value. You can count 1, 2, 3, 4, 5, 6. You're gonna count 1, 2, 3, 4, 5, 6, right? And then we keep going down. So one here, one here, one here, one here, one here, one here. And the median for 10 a.m. should be 70, right? Are we good?
Because multiplication and division are on the same level in terms of like priority operation.
Doesn't make sense. I know.
You were really just
Why the median of
that
10 a.m. is 70, guys?
is going to give you J squared.
So like I said, we need to get rid of like you just have to cover like from the small. Let's say I'm gonna cover like two data sets here. I'm gonna get rid of two biggest data sets here, and then 4, and then I get rid of 2 and 2. Correct? So the 4. So we actually get rid of 6 of them, and then we're gonna go to this 2, and then this 2 should be crossed out, and these 3 and this 3 should be crossed out, and then the minimum data set point we have to be 70. Are we good?
And this
Is that clear from what we're doing so far or no? Okay, so
B. So if we want to take X to the power of B to the lower floor, to the denominator, we just have to flip its exponents.
for the 11 a.m., why the smaller value 53 but not 9?
Here, what we're
Um,
actually doing. What we're
I mean,
doing is, well,
the
I want
smallest
to be able to like simplify.
the smallest value that we have was like
Well, I want to run this guy.
the smallest is 53, right? But the biggest value for 11 a.m. should be 87. So there's no value for 9 for 11 a.m. So the biggest value that you can possibly have for 11 a.m. should be set 87, right? I'm not sure if I answered your question.
End up with
Okay, so the same thing that we can look at the median for 11 a.m. that essentially going to give us some idea. So we're gonna do the same thing. We're gonna cross the number here. We cross 1, cross 1. We cross 2. We cross 2. We cross 2 here. We cross 2 here. We cross this. We cross this. And now it's so we got 1, 2, 3, 4, 5, 6. We cross 6 of them on the left. I'm saying on the right, and we also cross 1, 2, 3, 4, 5, 6. 6 of them on the left side. So apparently that the median for 11 a.m. should be the average between 71 and 72. So with that's gonna give us 71.5. Okay.
And again, the way to like if you're like during an exam, see something like this,
So now apparently that we can basically note the fact that the 11 a.m. have a high median score, and which class is more score in the 80?
Or JP divided
Apparently 10 a.m. because it has 1, 2, 3, 4, 5, 6, 7 score. Are we good?
0. And any number to the power of 0 is equal to 1. Including 2. But just like that is like kind of like the one of the like another one of the exponent rules.
Still got
Wait.
lab.
I have lab right after this.
Yeah, lab right after.
Yes,
Make
like
sure
12:30.
that you study.
Are we good?
You remember this?
Okay.
It was like unfortunately.
All right,
don't
I
remember
believe
myself.
that's pretty much it. And any
But-
question, any concern?
They make sense.
Any question?
Kind of like they start making sense. Like,
Oh,
it starts
hold on.
making
So
go,
which one has a high median
and-
score? Median score. So we look at that.
Right now.
So you go
Make sure
1, 2. Why this one's 10 a.m. It's supposed to be 11 a.m. So
From then you kind of the way you want to go
1,
about
2,
this
1, 2,
is
3,
for
4,
if you have
3, 4,
more
5, 6, 5, 6,
look at individual forms. Okay, so first of all, we look at the numerator.
58, 79, 77,
Each
right?
you see that we have more than one parenthesis, then you want to at least check whether or not there is like some distribution to it.
Oh yeah.
In this case,
I'm so sorry I forgot that one. So the median for that was supposed to
the
be
reason-
70 and 80. So that is I'm so sorry. So we crossed out these two, we crossed out these two, we crossed out these four, we crossed out these four, and now after that we crossed out these two, and then these two, this one, this one, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
The numerator is done. Let's move to the
Yeah, I don't.
start from
It's
this.
23 data sets. So 10 a.m. actually has the median equal to 70, right? It cannot be 80 for some reason. So
So like that's kind of like it's going to if you manage to start from the smallest, like if you teach yourself
okay.
always
And then we do the same thing. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we cross them out.
let's do like
And then yeah, I'll definitely get back to you this question. So for some reason, so it's just kind of you have I think
yes.
one way we can do it just have to make a list of all the data set point. But 6, 10, 12, 14, 16, 18, 20, 23, right?
Tuesday, I saw it.
And then
He literally came in and was like,
oh yeah. So the median for that was supposed to be we have to start from the left. So this the median supposed to be like 79 instead of
yes,
instead of 70. So I'm so sorry. We have to do the covering like that. Yeah.
so don't deal with the same situation.
So when you cost them out, when you see the question like that, you're gonna cost this, and you have to start from the left, from the right to the left instead of from the left to the right. This one you have to start from the left to the right, and then this, 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 and then 3, and then 3. So the median have to be 79. I'm so sorry. You have to start from the right to the left for this value. We do the same thing for this. So we're gonna cross that one, and then we have to start from the left. 1, 2, 1, 2, and then 1, 2, 3, and then 1, 2, 3. Yeah, this one is 71.5, but that one is actually it's actually 79. So that's a little different when you cross them out. Yeah.
Fraction and you're gonna have everything, which is again goes back to
so
why-
remember, in order to find a median, you have to cover the small value on the left and then the big value on the right. So the small value on the left,
what do we do?
it is so. Hold on a second. Let me just cross them out. So the small value on the left side, you have to do this, right? For example, we're going to do this. You're going to cover. So the big value on the right have to start from the left to the right, but the small value from the left, you have to start from the right, start here, right? You have to read that 60, 68, 69, 69, right? And then we do the same thing for that. And then now we have to start from the left to the right for the small value, and for the big value, you have to start from the left to the right. And then the same thing, you have to start with small value from the right to the left, and then that's from the left to the right, and then you have class 3 and class 3. And then the median should be 79. Okay, so that's a little different from when we're looking at when we find a median. Okay. All right. So anyway, so let's move up to the next part of the question and see how it's going to help us. We spent half an hour for nothing.
But if it-
Assuming that these weights for the not what I'm looking for, by the standard deviation of the population routing answers to the two decimal place. The standard deviation can be computed by, they do have a form for that, but when we do the standard deviation, it's actually not
we do what we
not
did
given.
there.
So, which is why I'm going to look at the
So what write this in a way to
computation standard deviation. Forms. Okay, so just want to let you know this is somewhat important. This is what we have for the standard deviation forms, but we need to get the computational, right? Computational.
They both go.
There actually two of them. So let me just pick the one that that's easier to compute instead of this. So we can pick this one. Okay, so this is the one.
And then I'm getting that.
J to the power of K.
No, just not.
Oh,
JK.
J times K. Oh, okay.
You know, in my mind.
Yeah, so if they cancel out, so you end up with just like
Yeah.
J to the, like, this is like, again.
So the sample standard deviation is it's given by this.
Just like, you're just like starting to do stuff.
Okay, this is the what we have for sample standard deviation. Let me just remove some of these.
It's going to like trick you into just like simplifying to something that is not true. You want to always like kind of double check your reasoning.
Yeah.
So in this case, like do the calculation actually. Like
Then we also have like this one's s equal to.
Which is equal to J to the power of 0.
Let me just rewrite that, just making
And
sure.
what do you think, what does everything to the power of 0 equal to? Right? And by the way, in the exams, like like in homework, like whenever like
All right, so this is what we have for the sample standard deviation and then the competition formula we have. So the sample standard deviation represent
time constraint and there's
represent the
you're comfortable enough that you kind of like go a little faster.
the average deviation
Like every single step.
of the data sets. Okay.
Like ideally.
Okay, so that's one way we can interpret that.
Like, I don't
It can be computed by taking over the deviation, which is the fluctuation from each data set point to the average. Okay, so the deviation is simply the difference between each data set minus the mean or minus the average. Okay, so that's the average deviation. You can think of that. The bigger the range, usually we have a big standard deviation, obviously. So now if the question asks us to compute a sample standard deviation on a calculator, I would suggest you to
as of right
pick
now,
on a calculator.
you
Okay.
want to like I recognize.
So first up, you have to hit the square root.
Every step.
We have to hit the
like some
x square for all of this. Okay. And then we also hit the big square root over here. And then now you're gonna minus this is the sum square, and then you send this to the calculator as well. I'm not sure if that works. Yes, that works. And then you're gonna hit that with the sums.
Yeah.
Okay.
Mm-hmm.
And then you're gonna square this.
So I understand how to do it, but.
Then after that, we divide it by 4. Okay. By 5, I'm so sorry. By 5, we have 5 data sets point.
Yeah. It's intuitive, right?
Yeah.
Well,
And
actually, so
finally, that we're gonna take the ratio, we have to divide it by n minus 1. So you're gonna do the whole thing.
I guess range wrap.
Yeah, it's kind of weird to.
So it's like not as intuitive.
2 divided by 5, 2 divided by so this is the whole population. So for the population standard deviation is basically the same thing, but we don't divide it by 1. So for the population standard deviation we call sigma. And then
As to like, okay, so how do I?
so that's we're not gonna do like
Just all of the.
we're gonna do the same thing over here, but without dividing by n minus 1. So what is the n? So the n is simply called the number of data set point that we have. So we don't minus 1 in this case, right?
Is
The n is a number of data sets.
that is going to.
Data sets. So we have like 5 data set, we just divide it by 5. When you have like 6 data sets, we divide it by 6. So we have the summations over here.
Why?
So that's the sum, right? That's the sum, okay,
-3
of the numbers, right? Sum of the values. And when we have like something like this x squared,
on this function, this point is not included, right? So the
so that's a
result
sum square.
being
That's a
is
sum square.
actually technically not included. The -3 is not included in the domain, which
Okay,
means that
so that's kind of different. So we have to square each value.
function
This is the sum of the square. We have to square each value and then we add them up. So this is what I call the sum of the square.
like by
And when you have something like this, this is the
as
square of the sums. It's kind of different from what we have here, right? And then
we're gonna
make sure we're gonna get this part, the sum of this is the square of the sum.
So how do we do that? Well, we simply communicate that with a round.
All right, so based on our example, I can simply compute
Exactly.
the sample standard deviation with, so this is the population. So the question says the entire population, and then we divide it by 5 because there's no n minus 1. So we get 2.09. Are we good?
Yeah, so it was flipped, right. But yeah, it's really just going from the smallest number.
2.097. So we're gonna get that at like 2.10 or something.
The absolute value of the number is not what counts here, because like if you have -4, -4
Any question?
is smaller than 0.
So let me just show you guys how to get it done. Because like I said, it's a very point strategy.
Which is like as much as it may seem obvious, like that is something that sometimes we want to remind yourself of. But yeah.
The population state deviation
That's good.
of like 2.1160 equal to 2.097, something like that. We write up to and that route up to 2.1, right? So the first thing we have to do, like I said, I'm gonna send let me just do that again. You might have to hit the square root first and hit divide. Okay. On a calculator, you have to hit square root, and divide. Are we good? So the standard deviation can also be called as the technical risk in terms of the financial analysis. We also have a lot of different things, like I said, but one of them is just once you measure how much is status that scatter away from the mean.
Yeah, show me something.
Oh, and then we're gonna hit divide, right? Hit divide A over B. Okay. And after that, we're gonna look at the forms that we have, the population standard deviation form. You have to do the you have to send the data to the calculator, right? Send it to the calculator, and then you have to hit this one, which is the sum of the square, and I think you have to hit that first before you can send it to the calculator, so that we don't make any mistakes on it. Yeah, that's one. And then you minus, and now you have to hit divide again. So that's a little there's a the two divisions. So the bottom is just 5. We divide by 5 and equal to 5. There are 5 data sets. Okay. And then we do the same thing, gonna hit the sum, the square of the sum, right? So you might want to hit the square first, so that we always have to take care of like exponents, division before we do the parentheses stuff. That's actually go against the opposite with the primitives that we have when you do it on calculator. And then we do the same thing, gonna send the data to the calculator, and then you're gonna hit the yeah, maybe you can hit it later on. I'm trying to, yeah, I think you have to do it later on. Just send it in the sum, and then now you're gonna box the entire thing, and then go to the second power, and then everything looks perfect, and then just have to hit equal. You got 2.10. Are we good? So that's the population standard deviation. So you can get it done on a calculator by going to, the standard data, right? Standard data
Uh-huh.
to the calculator.
Okay, one sec. I need to put on socks.
39. Should be a
And then
like
then
38. So it should be
then follow the forms, right?
one, something like one.
To compute standard deviation. Okay. Are we good? Is that good, people? You can try another one. You can do another one. This is literally going to be the same thing. First thing we have to do, you're gonna the question says to compute the population standard deviations, and we're gonna do square root first, and then hit divide, and then send this hit this first, right? So you have to do the square sorry, the sum of the square first, and send all of this to the calculator. And then after that, we're gonna do the same thing. Have to subtract, hit divide again. The bottom was how many data? We have 5 data sets. 1, 5, 5. This one you're gonna do send data, and then you're gonna hit the I mean no. We have to hit this first. And then now we're gonna send data to the calculator. And then out of that,
Or the exponent.
you have to box them, so that's the thing.
They keep at it. You're like as you see.
And let's see. You're gonna get
it ends up
4.049.
making sense eventually.
Are we good?
You gotta trust that like not getting it is kind of
All right, so any question? No. All right, so you can look at the list of forms right here, um, which can be found under this. Unfortunately, that we do not have the competition one. This one is actually, uh, I think you have to do the other way, but the competition one is actually much faster, right? And yeah, so okay. Anyway, so let's me to go to the next topics and see how it's gonna be. Okay, let me just go to the next one. And then the sample standard deviation, you're gonna do the same thing, but like I said, it's kind of different. Let me just move to this. So for the sample standard deviation, we just simply we do pretty much the same thing. So the first thing we have to do Like I said, we're gonna open a calculator. I'm gonna hit divide, hit square root and divide. Okay, so that's the first thing. Okay. And afterwards, we're going to, um, you know, like, so this one is n minus one. This it's 5 minus one, sorry, 6 minus one, and then it's kind of different. And then on top of that, we're going to hit this, and then now minus divide this. Okay, so that is the thing that we have to do for the next steps. Okay. Are we good? So this is n minus 1 be divided by n minus 1 compared to the other example. So the next thing that we have to do, like I said, so this one is going to be divided by n, which is 6. And then and after that, we're going to hit the sums here. And don't forget to hit the square, which is 2. Okay. Okay. And finally, they're going to send the data into the calculator. So you can send it to the calculator, and then you can send it to the calculator. I don't think that works. You click on it. I don't know what's happening with this. This doesn't.
Yeah.
Maybe you can try it again. Get some percent. Okay, that worked. You have to do this sum first before you hit the square, and then you can hit the square later on. I'm so sorry. You have to hit the sum first, and got 3.03.
If you want, so the one with the workshops of 12 by 50, take it if you want to, if you know you want to take calculus after. Okay, then yeah, then pre-calc is then 12 by 50 is a good, is the course for you.
What time do you teach her?
7:30.
No.
I mean, we'll see next.
Before
next
square.
semester. We don't have our assignments yet, so
He's here at 7:30.
yeah. We're all there at 7:30, all chirpy and.
I can't really
on the day.
magnify the calculator, so you might not be able to see it clearer from what we're doing so far.
Do that in the evening? Nah.
And then the answer that we computed for the sample standard deviation is 3.03.
But yeah, 7:30. It's okay.
Are we good?
It makes me productive, kind of right out the gate, which is actually pretty nice.
So I feel like that's pretty much it, right? Are we good? So when
They try.
we do with the population, we divide it by n, right?
My first semester.
So this is for the population, we divide by n.
Multivariable calculus at 8:40 in the morning, and that was an experience that I.
When it comes to the sample standard deviation, this is sample standard deviation. We divide it by n minus 1. So that's a different. This is the sample standard deviation, and this is the population standard deviation. Those are two different things. Okay.
We often shift it a little bit, like you usually work until the late in the evening and wake up later. So the like 8:40 feels like.
Since this
super
is
close to
the question
it
asks
makes
us
sense. It's probably like working on
to find the sample standard deviation,
yeah, like obviously like didn't work if you work like
not the population
like,
standard deviation.
waking up at 8:40 and going to class is kind of a lot.
Okay. So that's make it different from the previous section. We just have to divide it by n minus 1 for the sample when you compute it.
that argued that it was impossible to go to a 10 a.m. class. It was.
Oh wait, so the population mean was does population division that sample mean was X bar, right? So there's like some key syntax that we need to know. So population parameters. We have population mean denoted by a little, we call like one of the Greek letters, 12, number 12. We have this. We do have a video, so and then we also have this and the standard deviation, the population standard deviation. So we call this one sigma. Okay, this is a little thing. For the sample statistics, we do have the mean, which is using the X bar, right? And the standard deviation, the sample standard deviation. How we using S, the letter S to represent it. Okay. Right. And I feel like that's pretty much, so this one doesn't, requires any work. Just understand what it is. Yeah, this one's gonna be hard. You might see one of these questions like that on the exams. Unfortunately, we have to know how to compute sample standard deviation based on this. First, we have to estimate the means, right? We estimate the midpoint. And then we have to estimate the and then this is a frequency. Okay. And then the midpoint that we found between 8 and 12 will be 10. Okay. Between so that's gonna give us 5 frequency. Between 12 and 16 was 14. And we have this one equal to 5 frequency as well. And then between 16 and 20, we get the midpoint to 18. And that gives us 25 data. And then between 20 and 24, we get 22. That gives 35 data set. Between 22 and 28 with 26, that gives 10 of them, right? So we can think of that, right? Think of this. So think of that, right? Think of this as like like 5, like 10, repeat 5 times. 22 repeats 35 times, something like that. Okay, so then we can compute all of this. Okay. Are we good? So let me try to use a calculator and then this is coming from a sample, right? Is it coming from a sample? Yeah, it is a sample. So there's a sample standard deviation divided by n-1 sample standard deviation, right? Question ask, question is a sample.
That's,
So we compute sample standard deviation.
I think the other way, maybe if you were with textbooks also, like sometimes you can help me. I really love, I love it, just like looking at the textbook from the laptop.
So I'm not sure if that works, but so we need to know the number of data sets. The number of data was 80, right? So there was 80 data sets. Yeah, it's it doesn't really work that way. So when you and then you have to do it 80 times, so that doesn't make sense. So this one actually requires us to do the other way.
Oh. Don't spoil all the fun. Yeah.
So I'm so sorry. We have to use different format to compute the sample standard deviation. So we need to find the average, right? Estimated mean. Explore.
Yeah, I got the names of the instructors. I'll send them an email today.
And then we're gonna take like 10 times 5
Either way, like
plus 14 times
like
5 plus
get it back. Like 1 to 2 weeks, like more than 2 weeks, just for you.
18 times 25
Like, it's-
plus 22 times 35 plus 26 times 10
that, and, like,
over 80.
But that you bring it back, like all I will accept it. That is not how, like, in general, that is not the system that
Yeah.
you guys should use. So like if it happens once, that's fine. But if it happens more than once, I might like calculate. I would just say the half credit. If you like turn it back in and like 2 months later, that point was used of it. But yeah, for you, like how they should, you'll have like how once they give it back to like they'll break it up.
So we got the average should be about like 5 point
Then like take like you have
5.625.
the Tuesdays likely, and on Tuesday you'll have 2 weeks to.
I think it did something wrong.
You like think of it as you have 2 weeks, just to say like you don't have to like.
Yeah, 22 times 35. I'm so sorry. Yeah, there's a missing calculation. So 18 times 18 times 25 and 26 times 10. Yeah, I miscalculated. So 10 times 5 plus 14 times 5 plus 18 times 25 plus the 22 times 35 plus 26 times 10. The average should be around here, right? Around 20, right? So this is 20. So after that, we're gonna do the computational formulas that we have over here. Okay. So yeah, we actually have to do this one by one, unfortunately. So we're gonna compute you're gonna hit equal and then divide by n minus 1, which is 80 minus 1. And on top of that, we're going to take each frequency we have like 5 times the difference between the data and the average. So the data that we have was 10 minus the average was 20, and then you square it. Okay. So we do the same thing for the rest of them until we can finish the whole list. We do the same thing for 5 frequency times so this one 14 minus 20 square. Okay.
E non ha passa sostenito.
Plus
Tu?
you have to do the rest of them, like 25 times 18 minus 20 square plus so this one is 22 times so sorry. 35 is repeat 35 times 22 minus 20 square plus this one 26 times, I'm sorry, 10, we just repeat 10 times 26, that's the midpoint, minus minus 20 squared. So hopefully we can get all of this correctly. So we get 5 frequency for the first, the midpoint is 10. So we got 5 frequency for the second, the midpoint is 14. We got 35, 25 frequency from the midpoint equal to 18. 35 frequency from the midpoint equal to 22. And then 10 frequency from the midpoint equal to 26. All right, alrighty. So we just divided by n minus 1, which is 80. That is at minus 1. So we should be able to get it. We get 4.025. All right. So we got 4.0. Are we good?
Diciamo che in futuro, cioè, forse sono le 7:30, mi sento un po' in colpa a dire alle 7:30 non si dà. Però in futuro vi dirò, sappiate che a meno che non siete perché si prendete un autobus da capisco se ne arrivate 10 o 5 minuti tardi, però in generale alle 7:30. Sai che niente, oggi un po' molto su questo
So let me just show you like the math when you put it on a calculator so I can what is the better way? We can just look at the decimal calculator and I'll show you what it is.
erano dalle 10 alle 11.
Calculator. And all we have to do is just do this. So we have to hit square root, divide 5 times something like that. And then this one's 80 minus 1. Then, yeah, so we take the midpoint, subtract the mean, and take the square. And this is what we're supposed to do. Okay. Are we good? Like, so we can take so the midpoint was 10, the midpoint was 14 and something like that. Just, all we have to do is just simply like 10 minus 20 square plus, so the 5 frequency as well, like 14 minus 20 square plus, we got 25 frequency for 18 minus 20 square plus 35 frequency for 22 minus 20 square plus we got 10 frequency for 26 minus 20 square. So we get 4.025. Okay. Doesn't make sense. So this calculator gonna like you can see them what you want to do. Okay. So this is the frequency, right? This is the frequency. Those are frequency. Yeah. All right, so let's go to the next one. And this is a really hard question, so I would focus on that as well. The final summary, we just simply look for Q1, Q2, and Q3. Okay. Let me just start with that. So if you find like a smallest Q1, Q2, Q3, and the largest, right? So the final summary just basically help us like understand the shape of the data sets, and also is help us identify the outliers. Then can tell us the range of the data, whether it's school left or school right. So Q2 going to be called a median. Okay. And the Q1 is also the middle number data set, the mid data, right? Between the smallest and Q2. So that represent 25 percentile, right? So this one is 25 percentile. It's gonna divide the first 25% of populations, okay? The same thing for that. This one, you're gonna be like 50 percentile. It's gonna divide into like 50%, right? And this one gonna be called 75 percentile, which is the first 75% of the population. And then the Q3, we can also find Q3 by looking at the mid data between Q2, which is the median, and the largest, right? And that when you have like um when we have like two mid data set, when we have two middle data set, two mid data, we just add them up and divide it by two. And divide by two. The IQR is the middle half of the datas, right? It's the middle half of the datas. This is basically equal to Q3 minus Q1. That's the middle 50% of the populations. Okay, middle half of data. We can call this one middle class, obviously. So of data sets. Okay. It's include like 50% of the data. So so if you have a list of a data set, um we can figure out the minimum is 5, the lower quartile 25 percentile. You have to find a median first. So I would suggest people um put this here. Oops. So this is the smallest, and this is the largest. And now we can do the finger clusters of 1, 2, 1, 2, 3, 4, 5, 6. So 25 is Q2, right? So if Q2 is one of your data set value, we're gonna erase it, we cross them out. And then you have to look for Q1. So the key ones, so we're you're gonna get rid of D, get rid of D. So we're gonna be the difference between, so we have two mid data sets, right? So Q1 going to be the average between 13 and 13 is also 13. The same thing, and this one is two mid data set point. We don't count 25 when you look for Q3. So obviously we can have to take 31 plus 42 over 2 is 73 over 2. It's 36.5. Are we good? Okay. All right. So that's what we have. Any question, any concern regarding to the final summary? This is also a very important thing. The interquartile range is yeah, I forgot to is the question was asked is the IQR is Q3 minus Q1. So that simply taking 36.5, subtract 13, and then we get 23.5. All right, so that's the final answers. Okay. All right, so and then the rest of the topics can also be so the outlier is simply the data set. So you can use those things to look for Q1, Q3. So 11. So the Q2 was 82, and then the Q1 is 73, right? Something like that. And then the Q3 was 93. The interquartile range is the difference, the 20, right? And then the IQR, just set up the IQR times 1.5 is 30, subtract from Q1, so 73 minus 1.5 times IQR. So that's gonna be giving us 43, and plus 30 again is 123. If you want to see if there's any outliers, the answer yes. The outlier will be 18 and 186. So we can't set up the fans for the final summary. So the fans for the final summary can be computed based on um, uh, the the IQR. So we can take the Q1 plus 1.5 times the IQR. So this is what we call the lower. So subtract 1.5 times IQR. This is the lower fence. And then we can also construct the upper fence, which is Q3 plus 1.5 times IQR. Okay, so by giving this fence, and then we simply compute it for that previous question. You can set up fence by taking 13 minus 1.5 times 20.5, whatever. And then we also set up the upper fence, which is 36.5 plus 1.5 times IQR, which is 22.5. You can also get the upper fence, and then you can identify if they're the outliers. Usually, this question we do not have it. The outlier usually is something that is go out of like beyond a fence, right? So the outlier um go beyond the fence, right? Right? If you have found any value that's less than the lower fence or bigger than the upper fence, so that we call the outliers. Okay. All right. Any question? Okay, so I feel like that's pretty much for today. We are late for class, but just take attendance real quick and then I'll let you go. I'm so sorry I didn't see the message since I'm like too focused for that, trying to, get to this. We only have like a few left. Um how okay, you got that. Jasminer here, Malika here, Annie here, Rachel, Selena, Sean, Samina. Oh, yes, of course. Please, you can join the office hour today or tomorrow. That'd be great. Sarah, Selena is here. I don't see Selena. Okay. Sarah is here. Alexis is here. Z. Yeah. Yes. So the office hour listed on Brightspace, so you can please join in. I'll show you. I feel like the hardest competition should be on this part. This one is crazy hard. So I spent so much time on it. And then the other thing is to help you read, explain, read the explanation. If you don't understand it, just let me know, Marlene. It have to be online. It have to be online. So
That's
Marlene is here because we have like 20 people. So I think the rest of you should be good. I'm missing 2 people, so the rest of you should be present. Right? I have 30 students in the class.
Yeah, I think the ice that would help us. Oh my god, that's
All right, guys. So have a wonderful weekend. If you have any question, please come to the office hour either today, start from 2:20 until 4:20, or tomorrow from Saturday. Have a wonderful day. Take care.